Hello, this is Dr. Oz. In this video, I would like to show you an example of a data that has trend and also seasonality in it. Let's get started. So in this data set, I have 3 years of data and each year has 4 quarters. And you can see the historical sales here in terms of units. This could be dollar figures as well. The first thing I would like to do whenever I get a data like this is to create a scatter chart. So I highlight my data, insert, and then you will click insert scatter XY or bubble chart. And then here the first option, I like the first option, which is scatter chart. And you can see the scatter chart is created right here. Okay, so now what I would like to do is, based on the scatter chart, I would like to understand what's going on in my data. So first thing first, I like to do some designing things. You can use different designing options here. I like to use design number 6. Again, you could use different designs, but you could use, for example, this style 9. Maybe I will use 9. 6 is good, 9 is good. I will make some changes anyway. So you can see the historical sales here, and now I would like to add some axis titles. All right, click plus symbol, which is chart elements, and then here you will see axis titles, and let's label our y-axis as sales in units. All right, and my x-axis in this case is my quarters, so I will just put here quarter. Perfect. To increase the readability, what I'm going to do is eliminate the horizontal axis label, X grid lines. Click on one of those horizontal lines, press delete. Click on one of those vertical grid lines and press delete. Now you can see the data. And visually, you can obviously see here that there is an upward trend. However, I would like to quantify it. To do that, I will double click one of these values, which are the historical sales. That will bring format data series, and I will click on the first option here, and I would like to connect them with solid line, let's say blue. All right, so now you can see that those data points are connected. So let's show the trend line. I claim that there is an upward trend. I mean, visually I can see it, but let's see whether that's the case. So I will click on this plus symbol again, chart elements, and here you will check trend line. And let's add the equation and R-square value of the trend line by clicking on this arrow, and then click here more options. That will bring format trend line. And then here, if you click on this trend line options, I will use linear trend line, and I would like to show the equation on chart and display R-squared value. Let me just place this equation on the top right corner. All right, so you can see that the slope is positive, which is 52, and y is equal to mx plus b. So what does it tell me? This tells me that every single quarter increase will impact my sales by 52 units. Or in other words, I do expect to have higher and higher sales as quarters progress. So, all right, and R square here is almost 32%. What that tells me that 32% of the variation in Y or dependent variable, in this case sales, can be explained by the independent variable, which is quarters in this case, by using this linear trend line. Is it awesome? Not really. But is it horrible? Not really. So it looks like there's a trend, but this trend line itself could not explain the whole story for me. So what I'm gonna do is then look at the data. So this is my quarter 1, quarter 2, quarter 3, quarter 4, quarter 1, quarter 2, quarter 3, quarter 4, quarter 1, quarter 2, quarter 3, quarter 4. So you can see the trend here. All my quarter 3 values are my top values, and all my quarter 2 values are my low values. So that means that I sell more and more in quarter 3s, probably this holiday season, or if it's an ice cream example, summers. So that I need to consider some seasonality. So I can see from this behavior of this data that there is some seasonality. All right, so I will use two patterns, one trend line, two patterns of seasonality to make my forecast. All right, so let's get started. I can first start with the trend line because this is easier to grasp. So to be able to do that, I need to have my period numbers in a chronological order. Again, make sure that all your data is in chronological order, meaning that oldest data first, newest data last. So oldest to newest, oldest to most recent. So I will put period numbers here, starting from 1, 2, highlight those two numbers, right down corner, you can drag it down. All right, so I have overall 16 quarters in this forecasting method. I have 12 periods of data that is available for me. However, I put this one's black because I have no idea about these values. So this is what I'm trying to figure out. This is the future, all right? And no one really knows. So I'm trying to predict that. All right, so I will start with my pattern number one, which is the trend line or trend. So there are different ways to approach this. What I could do is I could just copy this formula because I already calculate my trend, Control C, and then paste it here, and then replace the X by times X, which is independent variable, period number. And then I could just drag it down. I really don't need the decimals, so I will eliminate decimals. And this is my trend. That means that these values are every single value on this linear dotted trend line. However, if you don't like this approach, because it's not that dynamic, you need to create a chart and then copy that equation from there. What you could do is update this equation by, instead of just copying and pasting, I can put here Excel's slope function. All right. And Excel slope function has two arguments. First argument is what are the y values or dependent variables. Dependent variables are historical sales. I will start from 1100 all the way to 1300. Comma, Excel is asking my x values, which are my period numbers, first 12 quarters. Again, it's important that you use these values because if you use this 1, 2, 3, 4, it repeats itself. But I want to have different period numbers for every single historical quarter. And I can do the same thing, by the way, by replacing this y-intercept by typing intercept. And XLY values are again dependent variables, which are these values, sales values, comma, X values are again period numbers. So this would calculate my trend line forecast. However, what I would like to do is I would like to drag it down. To be able to do that, I need to lock my erase. I'll highlight my values, press F4. And same thing here. Highlight them and press F4 to lock them. Or press enter. Now what I can do is drag it down and you will see that I will get exact same values. Perfect. So now I'm done. I'm all set with the first pattern, which is a trend line. What's next? So I need to consider some seasonality. As you see here, I'm overestimating the reality. Reality is these dots, and the forecast, trend line forecast, or simple linear regression line forecast is this line right here. So I'm overestimating here, underestimating here, over, under, over, under, over, under, and so on. So whenever I overestimate, I would like to multiply, whenever I overestimate right here, I would like to multiply this line by something less than 1 so that it will look more like this, curved. And whenever I'm underestimating reality like this, I would like to multiply that line by something greater than 1 so that it will look more like curved like this. All right, so how am I gonna do that? I need to calculate my ratios. So what's the ratio? Again, whenever I underestimate, like for example here I underestimate because the reality was 1100 and I estimate 1055, I need to multiply this value by something greater than 1. So to be able to calculate that ratio, you look at historical sales data, divide by your trend line forecast. Okay, now I can drag this one down. All right, obviously I don't have these ratios because I don't have historical data yet, so I can delete this. Excuse me. Now I would like to understand whether what's on average over or underestimation for every single quarter. That's why we call this one pattern number 2, seasonality. All right, so what I'm gonna do is I would like to understand on average how much I'm off on the first quarter and second quarter, third quarter and fourth quarter. So I will take the average ratio of the first quarters. All right, and then I can drag this one down for other quarters. All right, so these are the factors that I'm going to use. What does it tell me? On average, I am underestimating the reality by 8%, so that I need to multiply that by 1.08 to not underestimate anymore. Or I'm overestimating the quarter 4 values by 23%. How did I come up with 23%? 1 minus of this value. So I need to multiply the overestimated forecast by something less than 1. All right, so I need to calculate the same things for other years, which are exact same values. Instead of copy pasting it, I reference them so that everything will change dynamically if I change my data set. Same thing here, and I will drag it down. And again, same thing here, I will drag it down. And as you see here, year 1 seasonality index values are same as, maybe I should use a different color, same as year 2, and same as year 3, and same as year 4. Perfect. So now I have 2 patterns. Now I can make my forecast. All right, my forecast considering both trend line and seasonality will be this: P1 times P2 for a given period. All right, so I don't need decimals. I will click on comma and eliminate decimals. Perfect. So this is my forecast, and it's for future as well. Again, this is what I don't know. This is what I'm trying to figure out. So output of my model is literally this value. However, before really make this forecast or use this forecast, I need to make sure that my forecast is working properly. Otherwise, I may lose millions of dollars by buying inventory extra, and that they will become obsolete or will go bad or something like that. Or if I don't buy enough or produce enough, then basically I can satisfy the demand and lose sales. So now I need to validate my model. To validate my model, I need to calculate the error. I need to calculate squared error. I need to calculate absolute error. All right, so in Excel, these are easy to do. So error, if I do my forecast minus the reality, that will give me error. Looks like I overestimate the reality by 39 units. So if I just drag it down, overestimation, overestimation, underestimation. Whenever this number is negative, it's an underestimation. Of course, I cannot calculate it here because I do not have data for these values. Maybe I will just put something light black that shows us that I cannot really calculate these. All right, now if I take the square of these errors, that will give me the squared error. Why do I do that? Because when I ever calculate average error for my model overall, I don't want positive and negative numbers to cancel each other out. So I will just drag it down. And I can calculate the absolute value of these errors by using ABS function in Excel that will convert the negative values into positive numbers. Okay, so if I drag it down, you will see that now this negative 29 became 29, negative 57 became 57. All right, so what am I gonna do now? What I'm gonna do is I would like to calculate the error, average error. So average error. How am I gonna do that? Let me just drag this one a little bit down. So I will calculate my average error right here. Right, if I take the average of my errors, right here, that will give me my bias. So my model is biased by -4 units, which means that my model on average underestimating the reality by four units. All right, and I can take the average of the squared error and absolute error terms. Squared error term is giving me MSE, mean squared error, mean squared error. Again, I want this value to be as close as possible to 0. And in regression, we use this value to calculate the R-square. All right. And this is called MAD, mean absolute deviation. So this is showing me that on average, I'm off by 43 units. Okay, so is this good? I don't know, because 43 units out of what? If it's out of millions of units, it's pretty good. If it's out of 10 units, it's pretty horrible. If the magnitude is thousands of units, not too bad. So I need to understand that. Okay, so what I'm going to do is now I would like to calculate the percent, absolute percent errors. You can calculate absolute errors as well. Let me just calculate the absolute percent error. So how am I gonna do that? I will look at my absolute error, divide by my real sales. So that will give me the absolute percent error. So you can see that I'm off by 4% here. And if I drag it down, you can see that I'm off by 4%, 8%, 10% is the biggest I'm off by. All right, but to better understand what's going on here, what I can do is I can calculate the average, similar to other error measures or accuracy measures. I can take the average absolute percent error, and that will give me on average how much I'm off. So it looks like I'm off by 4% on average, which is, I would say, pretty good. So we call this one MAPE, mean absolute percent error. So I like this measure a lot. So I would focus on this measure to validate my model. So on average, my model is off by 4%, and I think that's really good forecast. So now I validated my model. So I think that forecasting for this company using seasonality and trend line together, two patterns together, is a great idea. Another way to validate this model is to calculate standard deviation. Standard deviation. So how do I calculate standard deviation? We can calculate standard deviation by taking the square root of mean squared errors. All right, let's do that. Taking square root of mean squared errors. So you can see that my standard deviation is 48 units. I don't need the decimals. So now I can calculate my error in terms of number of standard deviation to see whether my deviation is big. Okay, so what can I do is that I can look at my absolute error and divide by my standard deviation, and that will give me the error in terms of number of standard deviation. And you can see here that my error is 0.8 standard deviation away from my reality. So let me just lock the standard deviation because I will use it over and over again. And then you can drag it down and you can see that standard deviation is changing in terms of error in terms of the real data. So how do I interpret this? So whenever I have error that is less than 1 standard deviation, that is so normal, which means that we will always have some natural phenomenon that we cannot explain with our data, with our forecasting model. So everything that's less than 1 standard deviation error, that's absolutely perfect. And everything between 1 to 2 standard deviation, I would say it's still pretty good. So if you had any standard deviation that is greater than 2 standard deviation, by normal distribution, we know that is less than 5% chance. That's an outlier. That means that your model is not explaining that specific period very well. So in this case, again, I validated my model using the error in terms of number of standard deviations and also in terms of mean absolute percent error. I think this model is perfect, so I can use it to forecast the future. Of course, to be able to see the results, I need to wait 1 more year to see whether my forecast is good for the future. That's it for this video. Until next video, enjoy business analytics.